Hello, welcome back to my channel. So my name is Ayush Kumar. My USN is 1VE23CS022 and my semester is second sem, and my section is Audi, and the subject today which we are going to learn is Introduction to Civil Engineering for CSE stream, and subject code is BESCK204A. Our course teacher is Miss Latta MS. So let's get started. So my topic is Introduction to Structural Elements in Civil Engineering. So let's get started. So first we have foundation. So foundation is one of the structure which we would be learning about. So what is foundation? A foundation is a structural element that transforms the load from a building or structure to the underlying soil or rock. Foundations are crucial because they provide stability, support, and prevent excessive settlement or movement of the structure. They are typically placed below the ground level, and they are designed, as you can see in the photo, they're basically below the ground level, and they are designed in such a way that they can bear a lot of weight. So there are types of foundation. So foundations can be also shallow, example, spread footing or deep. Depending on the structure, for example, if there is a huge structure which is like widely spread, then we can use a spread footing. And or else if we have a very large structure which is very horizontally very long in size, then we can use the deep shallows, example piles, caissons, depending on soil condition and structural requirements, load transfer. So foundations are designed to safely transfer the weights of the building to the underlying soil, ensuring structural stability, as I've said at the starting part of the video. Next, we have site condition. The foundation type is chosen based on factors like soil bearing capacity, groundwater level, and slope of land. So soil bearing, there can also be another thing at soil, which is basically soil testing, which you would be paying a bit of amount, so that they'll test the soil that if it is capable of bearing that much of weight around. That's what they say, soil bearing. Because if a soil cannot bear that much weight, you cannot actually construct a thing like that. Next, we have a plinth. As you can see in the photo, that's how a plinth looks. So plinth is a raised solid base that supports the foundation of a building. It serves as a critical structure element, elevating the structure and protecting it from the water damage, erosion, and other environmental factors. As you can see, it is raised from the normal ground level so that there might not be any kind of water uh, passing through it and damage the internal structure. So there are also certain things, other environmental factors which provides a stable foundation for the building. Raising the structure above the ground level will improve drainage and prevent moisture intrusion. That's what I said. So adds architectural interest and aesthetic appeal to the building design. So next we have lintels. Uh, so lintels are basically horizontal structure elements that span opening in walls such as door, window. They play a crucial role in distributing the weight of the wall above, preventing collapse. Careful lintel design ensure adequate strength and load bearing capacity. As you can see here, I have taken an image which is having a door and it is having a structure like this, a beautiful structure like this. So it basically helps the overall structure which is above it to not collapse. So the size, material, and reinforcement of lintels must be precisely calculated based on factors like opening width, wall thickness, and expected loads. Proper lintel placement and integration with the surrounding masonry is essential for structural integrity. So that's it with lintels. Next we have cheja. So architectural and functional aspects. So we have a decorative cheja. Chejas are basically decorative architectural overhangs that provides both functional and aesthetic benefits. So uh, their intuitive carving and design adds visual interest to building facades. So basically in Europe, you'll see most of these things like, for example, the Romans, which may have built overall. So they give very aesthetic looks to the overall structure, as they have mentioned over here, and they also provide a good functionality. So next, shading and shelter. So the primary function of Cheja is to provide shade and shelter from the sun and rain. You can kind of think it as a roof, which basically provides shade and shelter from the sun and rain, protecting the opening and walls of the building. Next, we have architectural integration. Well-designed chechas are an integral part of the building architectural, complementing the overall aesthetic while serving important practical purpose. As you can see, there is a building over here, which is a completely modern day building, which usually maximum parts of the building are built. So as you can see, there is a probably there is a roof over top, which provides shelter and also providing the overall aesthetic for a modern house. Next, we have masonry walls, which gives the structural integrity and reinforcement. Structural stability. Masonry walls composed of bricks or concrete blocks are fundamental structural elements that provide load-bearing support and ensuring the overall stability of building. Next, we have reinforcement techniques. Masonry walls can be reinforced with steel bars or mesh embedded within the mortar joints to enhance their tensile strength and resistance to cracking or collapse. Architectural aesthetics exposed masonry walls can also contribute to the aesthetic appeal of the building, as we have seen in the earlier part of the building. Next, code compliance. Proper design and construction of masonry walls are crucial to meet the building codes and ensure the structural integrity and safety of the structure. Next, we have columns, load bearing capacity and placement. Structural integrity columns are critical load bearing elements that support the weight of the building, floor, wall, and roof. So, their design ensures sufficient strength to withstand the imposed loads with compromising the overall structural integrity. As you can see, the columns are placed at certain places where it can actually hold the maximum weightage of the upper roof so that it does not collapse. So placement consideration, yeah, the same thing which I said, it should be placed at a certain geographical location where it can actually load the maximum weight of it, and it should be strongly weighed so that it does not collapse at any certain region. Material selection column can be constructed using various materials such as reinforced concrete, steel, or timber, each with its own advantages and application. The choice of material depends on factors like load requirement, building codes, and architectural design preference. So next we have beams. So we also use a thing called beams, which is spanning capability and reinforcement, load bearing, distributing loads across the structure, reinforcement, enhancing strength and durability, spanning, connecting structural elements. The beams are essentially structures that can span, opening, and distribute loads throughout the building. The spanning capability are crucial for transferring weights from floor, wall, and roofs to the support columns and foundation. Then we have reinforcement beams with steel, concrete, or other materials enhances their load bearing capacity and ensures the overall structural integrity of the construction. So next we have slabs. As you can see, there is a slab over here, and there is an iron rod coming through it, which is basically a beam. Sorry, that's not a beam. That's basically an iron rod coming through it. Next we have slabs, which are basically distributed around horizontal load distribution, load transfer. As like anything else, this also has a certain load which it can withstand before it can collapse. So slabs transfer horizontal loads such as wind, seismic forces to the support beams and columns below. Reinforcement. Slabs are reinforced with steel bars or, as I said, these are the iron bars or a steel bar. Iron bars usually get rusted, so they use a steel bar so that it does not get rusted easily to enhance its strength and ability to withstand tensile strength. Span configuration. The slab span and support condition impact how load are distributed, affecting the required thickness and reinforcement. So we have come to the end of the video, where we are going to talk about the conclusion and key takeaways about the video. First, we have integrated design, which gives the structural element with harmony to ensure overall stability and integrity of a building. Attention to detail, careful consideration of factors like load bearing capacity, reinforcement, and architectural aesthetics in crucial in engineering, civil engineering design. Continuous learning. As construction technique and materials evolve, civil engineers must stay up to date to optimize building structures. So that's it for the video of the structures. Hope you like the video. If you enjoyed the video, surely give a like down there and give a comment about how I can improve the video for the next time. So that's it for the video. Thank you. I had all and then most of you, some and now.